Welcome to the Deep Dive. Our mission today is, well, it's a journey spanning about 115 years, looking at the very bedrock of the masonry trade.
It really is.
We are taking the ultimate efficiency guru, Frank Gilbreth, and his incredibly detailed 1909 book, Bricklaying System, and putting it head-to-head against the modern gold standard.
Just a 2024 Canadian red seal brick and stonemason, the 401A.
Exactly.
And it's a truly fascinating comparison. I mean, primarily because we're not just looking at tools, even though, a lot of them are surprisingly recognizable.
Right.
We're looking at a profound philosophical shift in what skill even means. Gilbreth was, and you can't overstate this, singularly obsessed with eliminating delay.
Just any wasted time.
Any wasted labor, any unnecessary motion to get to what he called the one best way. I mean, he was measuring human effort down to the millisecond.
And the modern mason, governed by organizations like Skilled Trades Ontario and the Red Seal program, seems to have traded that brutal focus on motion for this massive emphasis on codified expertise, on safety, complex engineering standards.
Precisely. You've hit on the core of it. If we're asking what the essential difference is, it really boils down to autonomy versus optimization. Gilbreth saw the mason as a component, a piece in an optimized machine. The Red Seal system trains the mason to be an autonomous site manager, a code compliance officer, all of it backed by really extensive technical knowledge.
Okay, so let's unpack that. If a skilled mason from 1909, one of Gilbreth's guys, somehow landed on a modern Toronto job site, would they even recognize the craft?
That's the question.
And maybe more importantly, would they have the knowledge to pass the Red Seal exam today? Are we just faster now because of machinery, or have we fundamentally changed what the term skilled bricklayer actually means?
Let's get into it.
We have to start at the foundation, right? The things that have stayed absolutely constant. Let's look at the enduring craft, the traditions we've kept.
Right. And the enduring nature of masonry. It's really rooted in the physical reality of joining units, brick, stone, whatever, with a tight line and some mortar. Gilbreth understood that quality was, well, it was non-negotiable, even with his obsession with speed.
That's a really important point.
It is. It's critical to remember his rules explicitly stated they were never for shortcuts that would compromise the best workmanship. He insisted the quality of the finished wall had to be remembered long after every other consideration, like speed or cost, was forgotten.
That core principle, that's the constant.
It's the through line across the century, a focus on lasting quality.
And that emphasis on permanence, it has to start with layout and alignment. When you really dive into his 1909 book, you realize the physical tools for alignment, the ones that govern the vertical and horizontal plane, they're basically the same ones we use today.
Even with lasers, yeah.
Even with lasers, we're talking about the fundamentals, the story pole and the line.
And this is where the continuity of the trade is just so clear. Gilbreth saw the story pole as absolutely essential. And this isn't, a complicated piece of tech. It's just a long piece of wood or metal.
A stick with marks on it.
A stick with marks on it, but precisely marked with the intended height of every single component for that section of wall. The courses, the window and door openings, projections, beams, all of it. It guides everything.
And here's a detail that is it's perfect. It crosses the century divide with total fidelity. Gilbreth mandated that the marks on the story pole must represent the top edge of the brick.
Not the center of the mortar joint.
Why is that so important?
Well, that tiny detail ensures consistent course height across the entire project. If you mark the center of the joint, even a tiny variation in your mortar bed thickness, it would multiply over dozens of courses.
So you'd be off by inches at the top.
Exactly. Your windowsill or your plate line would be completely off. By marking the top edge of the brick, the mason is constantly checking that cumulative height, ensuring accuracy. Even today, with lasers for the initial setup, a physical story pole or a marked reference is still the ultimate, non-electronic quality check.
That's basically precision engineering with just wood and chalk.
That's what it is.
And that precision, it carries over directly to the application itself, the line work. Using a tight line to guide the top edge of each brick. That's paramount. But Gilbreth also highlighted a really specific physical skill that separates the good from the great.
The set-in or the roll.
Exactly, the roll of the brick.
This is a beautiful piece of craft knowledge. The roll is that subtle movement a mason does right as they set the brick into the mortar. If that roll is inaccurate, if the brick isn't seated uniformly, Gilbreth points out it becomes severely visible when the sun casts those long, horizontal shadows across the finished wall.
So the sun becomes the ultimate inspector.
It's the ultimate quality assurance test because nature reveals any inconsistency that our eyes might miss. It just speaks to a deep, practical understanding of how light works with masonry texture.
Which also means you need a high level of physical consistency in your mortar bed to begin with. That's a skill you only get through repetition. And Gilbreth, even with his efficiency obsession, wasn't just relying on the story pole or the line. He mandated this powerful layer of old-school redundancy.
Checking all the major dimensions with a wooden pole of the exact length.
He made them do this multiple times, both in the length and the height of the wall.
Yeah, that's the definition of belt and suspenders quality control. This final check was required no matter what other means you used for layout. It speaks to his recognition that even his perfect, optimized system needed deliberate, manual checks against cumulative error.
You're checking your math in multiple physical ways.
That's it, making sure the work is absolutely square and dimensionally accurate. It's a principle that no amount of technology has really replaced on large structural projects.
So the fundamentals of alignment, they're kind of frozen in time, dictated by the geometry of the brick itself. Okay, so moving beyond that, let's talk about language. Because if the 1909 Mason and the 2024 Red Seal Mason met, they'd understand each other instantly.
Oh, absolutely. The kinship of tools and terminology is absolute. The trowel is still king.
Right.
And the primary laying methods, whether you call it pick and dip, stringing mortar, the Western method, whatever, it all revolves around that one tool. And the language of bond, the structural way the bricks interlock, is identical.
Gilbreth's glossary defines the basics perfectly. The header is a brick laid so its end shows on the face. The stretcher is laid so its long side shows. They both know what courses are, what withes are.
He defined a withe as the vertical tier, usually about 4 inches thick.
It's the same language.
And, while the obvious reason for mortar is to get the part to the right height, distribute weight, and keep out the weather, Gilbreth gives us this deeper structural insight into the real purpose of bond.
Which is what?
It's to make the bricks stand up and carry their weight, even if there is no adhesion between the brick and the mortar.
Wow. Okay, say that again.
The structure itself, the interlocking pattern, should hold the wall up, even if the chemical bond of the mortar fails because of bad curing or something. That is a foundational, crucial distinction that comes from centuries of building solid mass masonry walls.
So the structure holds even if the glue fails.
That's the principle. And it dictates why all walls have to be built with overlapping continuous bonds.
Which makes perfect structural sense for the heavy load-bearing walls that were common in his time. And speaking of which, he required all walls to be laid out to bond before you even started laying. But this was essential for a reason that's, well, it's mostly obsolete today.
The inconsistency of the materials.
Yeah.
That is such a crucial historical point. Gilbreth was dealing with common brick that was often called run-of-kiln quality. And we need to be clear what that means. These bricks varied a lot in length, height, texture, all because of unequal firing in the kiln.
So the mason was constantly problem-solving on the fly.
Constantly. They had to adjust the bond to reduce the need for cutting, especially trying to minimize using long bats, those cut pieces that would mess up the look or the structural integrity of the bond pattern.
So a huge amount of the mason's skill back then was just dedicated to micro-adjusting the bond course by course to deal with crappy materials.
Exactly. It was a constant field problem. Modern manufacturing has largely solved this. Bricks today, especially for commercial use, are dimensionally consistent to really tight tolerances. So that removes the need for that specific kind of constant, taxing field adjustment.
But the principle is still there.
The principle of anticipating your bond, calculating your modules, and pre-planning the layout to minimize cutting, that's still essential. It ties the two eras together, even if the challenge isn't as severe.
So, story pole, tight line, header, stretcher, bond, they all endure. Okay, let's look at how the skill is transferred. The hierarchy of skill. Journeyman versus apprentice. This relationship is also a century old, but the philosophy behind it, that seems to have fractured.
The relationship itself is still the backbone of the trade, no matter the era. In Gilbreth's time, apprentices learned speed and skill through sheer practice. They were told explicitly they had to start where looks are not important, and they had to be forced to lay brick using quick, necessary motions.
A real baptism by fire.
Totally, focused purely on physical proficiency and output. But Gilbreth was actually highly critical of that traditional, just observational way of learning.
He warned apprentices against learning the slow method from traditional journeymen.
He did. He said they were teaching unnecessary motions. His hyper-rational system was partly designed to bypass what he saw as a flawed, anecdotal teaching structure.
He basically saw the traditional journeyman as an incompetent teacher.
He did. An incompetent teacher whose ingrained bad habits were just being passed down, crippling efficiency for generations.
But then you look at the modern Canadian Red Seal system, and it still fundamentally relies on this hierarchy. The apprenticeship involves 4,880 hours of practical training provided on the job by a journey person.
Right, so the mechanism of mentorship is ancient, but the context is what's new. The modern apprentice is learning the practical trade under a mentor, sure, but they're also doing mandatory formal education to understand the codes, the chemistry, the standards that now govern the work.
That's the difference.
In 1909, the journeyman taught you skill, and maybe the why of the bond. Today, the journeyman is teaching the skill alongside a massive body of regulatory and material science knowledge.
Which sets the stage perfectly for the central conflict here. We've established that the what of bricklaying, the basic motions, tools, language, is unchanged. But Gilbreth's great contribution wasn't in the what, it was in the hyper-specific, almost totalitarian how. Let's transition into Gilbreth's time. Segment 2. The abandoned obsession Gilbreth's motion study and efficiency machine.
This is where the two philosophies just completely diverge. Gilbreth wasn't just watching masons. He was applying the very definition of motion study, the forensic examination of the value, time, and sequence of motions for producing the greatest results in the least time with the least effort and fatigue.
So scientific management?
It was a genesis of it, and masonry was his laboratory.
And he had this profound observation about speed that really challenged how people thought about it. He found that the fastest and generally the best bricklayers were the ones who used the fewest motions.
Not the ones who were naturally the quickest.
Which is counterintuitive.
It is, but it makes perfect sense. If a mason is quick, but uses 5 unnecessary motions for every brick, a slower, more deliberate mason who only uses the 2 or 3 necessary motions will eventually outpace him, just through accumulated economy of effort over a whole day.
So his system wasn't about teaching raw speed?
No, it was about imposing a disciplined, efficient sequence. He wanted to eliminate the wrong way in the incompetent teacher through these formalized motion charts. It was creating this sort of unnatural, rationalized training designed for maximum output with minimum fatigue.
The focus was on eliminating what he called delay, any moment a man wasn't actively laying brick.
Exactly. And since he couldn't control the quality of the raw materials, he controlled the material supply chain itself. Which brings us to the very specialized Gilbreth packet system.
This system is just a testament to his obsession.
It really is.
It's fascinating because it addresses a logistics problem that, modern masons barely even think about. Material consistency and pre-handling. He has an entire chapter on this system where bricks were pre-sorted, sometimes even cleaned, and then stacked neatly on these wooden trays or packets.
And the whole goal of the packet system was to make sure the mason never wasted a single motion looking at a brick to find its best face. Remember, they're dealing with run-of-kiln brick. For handmade brick, the rougher side was usually the top. Gilbreth said the mason could detect the natural bottom, which was narrower, purely by feel.
That is micromanagement on a whole other level. The system basically took the quality inspection and sorting task, which might take a fraction of a second for the mason, and gave it to lower-paid laborers, the tenders, who prepared the packets.
Precisely. The mason just received a ready-to-lay unit. The system dictated the bricks had to be laid with the wide surface up. The packets took the decision-making process completely away from the bricklayer. This required organizing specialized labor units just to move these packs from the stockpile to the wall, all to minimize handling by the actual highly paid mason.
And even in the logistics, he had strict rules. He noted it was easier and quicker for the tender to unload packs from the wheelbarrow onto the mason's platform than to lower them to the floor. Every single movement was scrutinized.
And this leads us right to why we abandoned it. That level of focus on manual material staging is completely gone today.
Right.
Because modern, mass-produced brick is so dimensionally consistent that the need to pre-sort for a best face or for size is obsolete. We've replaced Gilbreth's constant human micromanagement and his complex packet system with industrial standardization.
We outsourced his efficiency problem to the automated factory floor.
A much more elegant solution.
That's a great way to put it. But the most iconic part of his system has to be the scaffolding and the extreme competitive environment he created. This is pure Gilbreth.
Oh yeah, this is the height of his ergonomic thinking, applied at scale. The non-stoop scaffold and the race for speed. Gilbreth actually patented a scaffold designed specifically to keep the bricklayer at a constant optimal height relative to the wall.
And this wasn't just for comfort. It was scientifically calculated to eliminate two major efficiency killers: stooping over to pick up brick and mortar, and stooping or reaching to lay them.
Eliminating bending, which causes fatigue and breaks your rhythm, was central to his whole philosophy.
And he had these militaristic rules about when to use it. He insisted the scaffold had to be set up or raised once the wall reached exactly 3 feet 8 inches above the floor.
3'8", not 3'7", not 4 feet.
Why that specific height?
Because he saw that masons stuck to the old-fashioned custom of building the wall up to 5 feet high from a standard trestle scaffold. That extra 1.5 feet meant the mason had to bend or stoop for nearly 2 feet of the wall's height, which killed efficiency. Gilbreth's superintendents had to monitor this constantly. It just shows how much he distrusted traditional habits.
And this system led to a hyper-competitive, almost athletic environment. He openly encouraged athletic contests among gangs of bricklayers.
And it wasn't just friendly competition, it was a high-stakes public performance. The management was built to ensure zero downtime. Foremen were told to watch specifically for any man standing idle, whether they were loafing, at a stock, or finished their bit. Delay was the enemy.
And he monetized it. Scores were kept on a large blackboard visible to all the men on all the gangs. This contest ran all day, often with extra pay as a reward for the winning team.
Can you imagine the pressure? Your performance is literally on public display for everyone to see, all day long. It's an intense form of extrinsic motivation, designed purely to maximize output.
And to prevent those delays, the site itself was managed with military precision. The general superintendent had a 60-foot-high tower.
Equipped with a telephone, a megaphone, and field glasses.
A megaphone and a 60-foot tower. That's not construction management. That sounds like the central command for a small army.
He was preventing logistical delays, the most common cause of downtime. If a gang of masons ran out of mortar or brick, that was seconds or minutes of wasted high-value labor. The man in the tower could see everything. When a foreman needed brick, he'd shout through his megaphone to a boy on the tower, who would then instantly relay instructions to the transportation foreman directing the carts.
So Gilbreth created this intensely centralized, competitive, and ergonomically optimized environment, all designed to squeeze every last unnecessary motion and delay out of the process.
It's a pinnacle of that early 20th century industrial management philosophy. But today, that focus has shifted almost entirely away from competitive speed and towards regulation and standardized knowledge.
And that shift is the core of our comparison. While Gilbreth solved the efficiency problem with relentless observation, the modern trade solved the longevity and compliance problem with education and strict codes. This brings us right to segment 3.
Exactly.
So we've left the time and motion study behind. We've abandoned the scoreboard, the megaphone tower, and the packets. Segment 3, the modern red seal, knowledge codes, and the classroom. This is the 2024 reality.
And the modern system completely changes the criteria for entry and success. The Red Seal standard means a mason has achieved Canada's national standard of proficiency. This isn't just about showing up and laying brick fast. It's about a verifiable, documented body of knowledge that lets you work safely and correctly anywhere in the country.
And the commitment is huge. That's the first major deviation from Gilbreth's model. The total apprenticeship is 5,600 hours, about 3 years. And while almost 5,000 of those hours are on the job, there's a mandatory 720 hours of in-school technical training.
That mandatory classroom time is the complete antithesis of Gilbreth's model. He tried to bypass the incompetent teacher by formalizing motions. The Red Seal system mandates formal education to interpret and apply a complex web of technical standards that just didn't exist in 1909.
And it's fascinating to look at what that modern knowledge requirement entails. The general learning outcomes say apprentices must be able to interpret architectural drawings, specs, contract documents, and critically, building codes.
Both national and Ontario codes. They have to interpret CSA masonry standards like CSA A371 safety codes and be able to estimate time and material costs.
That curriculum means the modern Red Seal Mason is trained to think like a structural technician, not just a skilled laborer. They have to understand how their work fits into the entire building envelope, especially since a lot of modern masonry is a cladding system, a veneer, not the pure load-bearing mass Gilbreth was building.
And that requires deep knowledge of flashing, weep holes, ties, movement joints, things that determine the longevity of the structure, not just how fast it went up.
Can you elaborate on that? For a listener who knows the basics, why is interpreting a document like CSA A371 so essential today when Gilbreth never needed it?
Well, CSA A371 is basically the engineering Bible for masonry in Canada.
Yeah.
It dictates requirements for everything from anchor types and spacing to the crucial design of expansion joints and flashing systems. When Gilbreth built a solid, thick wall, durability was just inherent in mass. Today, with thinner veneers and complex insulation requirements, if you fail to follow CSA standards on something like installing ties or integrating a moisture barrier, you can cause catastrophic building envelope failure, massive water damage, structural deterioration, all within just a few decades.
So the stakes are completely different. A modern mason's failure isn't just a wavy wall, it's a costly, code-violating structural flaw.
Exactly. The shift is from physical skill being the main metric to compliance and technical knowledge being the foundation that skill is built on. And when you look at the Level 1 curriculum, this priority becomes crystal clear.
So let's look at what we learn now. The single biggest segment of instruction in Level 1 is dedicated to mortar.
It's astonishing, and it's necessary.
Right.
Level 1 dedicates a massive 68 hours just to mortar, 9 hours of theory, 59 hours of practical. That huge time investment tells you that a deep understanding of chemistry, mixing, hydration, all of it is prioritized above everything else.
It's the science of the joint. Gilbreth focused on laying the brick fast. The modern mason has to understand the chemistry of the joint, why Type S mortar is different than Type N, how admixtures affect freeze-thaw resistance,
And how the mortar's strength affects the overall structural rating of the entire wall assembly. They also have to understand ambient conditions. Gilbreth just had to keep the mortar wet. The Red Seal mason needs to know the impact of temperature, humidity, especially in the Canadian climate. A mistake with mortar in sub-zero weather is a multi-million-dollar problem.
And then there's the overwhelming focus on regulation, which is the total opposite of Gilbreth's competitive scorekeeping world.
Mandatory code compliance takes up 20 hours of specific instruction time. This is where the Gilbreth model just completely collapses in the modern world. Training requires specific time spent on the Ontario Health and Safety Act, the Workers' Compensation Act, the Environmental Protection Act.
We have to pause on that. 20 hours just on safety compliance is a lot. What are the key safety concerns that need that kind of structured classroom time that Gilbreth's guy on the 60-foot tower just ignored?
3 main threats. First, working at heights. Modern scaffolds are regulated. You need extensive training in fall protection, harnesses, anchor points. None of that existed in 1909. Second, material handling and ergonomics. Gilbreth had his non-stoop scaffold, but the modern focus is on mechanical lifts and safety training to prevent chronic injuries from lifting heavy blocks all day.
And the third, I'm guessing it's an environmental health concern.
It's silica dust. Cutting brick, stone, or block generates crystalline silica dust, which is a severe respiratory hazard that causes silicosis. Modern masons have to be trained in mandatory engineering controls like wet cutting, using HEPA vacuums, and proper respirator use. This is a life-and-death regulatory requirement that has totally replaced Gilbreth's speed metrics.
Compliance replaces efficiency. And this formalized regulation goes beyond the work phase. Topics like worksite preparation, acclimatizing the worksite, clean and disassemble site, they account for 50 hours total in Level 1.
So in Gilbreth's world, management was outsourced to a man with a megaphone on a tower, and speed was the metric. In the Red Seal world, the mason is trained to manage the site conditions, follow strict safety and environmental protocols, and understand the chemistry of the build all before they even get their ticket. It's a shift from production management to risk and quality management.
And here is where it gets really interesting, tying back to that incompetent teacher idea that Gilbreth was so afraid of, the future of learning and how technology is changing the training model again.
We're seeing this new wave of innovation in technical schools, especially in Canada, with the adoption of augmented reality and virtual reality for trades like welding and construction.
The benefits of virtual training seem tailor-made to solve the traditional problems of apprenticeship while addressing Gilbreth's main critique: the inconsistent quality of instruction. AR and VR offer a secure, supervised, and risk-free environment.
I mean, think about the logistics of setting up a complex scaffold or a specialized wall assembly like a rain screen system for a total novice. It's expensive, it takes time, it's potentially dangerous. AR/VR simulations they solve this. You can run through it 100 times risk-free.
And crucially, this technology gives you immediate feedback and real-time progress tracking. It's far more precise than a journeyman's verbal correction. The system can track your mortar bed thickness, plumb, level, the motion of your trowel, and give you instant objective data.
Which helps you correct errors right away and become more self-assured. It bridges that gap between abstract theory and complex practice. You can visualize a flashing detail or a complex bond pattern without having to physically tear down and rebuild costly masonry units. It eliminates the fear of making a big mistake.
It also gives an accessibility that Gilbreth couldn't have imagined. Virtual tools mean remote learners can participate in complex simulations no matter where they are. It democratizes access to high-quality practical experience.
If Gilbreth's great contribution was eliminating unnecessary motions through structured rules, modern VR training is about eliminating unnecessary mistakes and dramatically increasing knowledge retention by creating perfect, repeatable simulations. It's the ultimate formalized instruction, a much more powerful version of his motion charts.
It's the rationalized learning system he dreamed of, just delivered digitally.
Exactly.
So that brings us to our final review of the contrast. We've gone from the 60-foot efficiency tower and the scorecard to the Red Seal classroom and the VR headset. Gilbreth focused on motion to eliminate delay and unnecessary labor in a system plagued by inconsistent materials and what he saw as flawed teaching.
And the modern Red Seal focuses on knowledge, code, and material science to ensure durability, longevity, and most importantly, safety. All of it supported by consistent manufacturing and highly structured, formalized training.
Gilbreth wanted the one best way defined by minimized motions, a quantifiable speed metric. The Red Seal goal is the one best standard, defined by compliance with the National Building Code, CSA standards, and comprehensive safety training.
The two eras are fundamentally different, not in the physical act of laying a brick, but in the definition of skill. For Gilbreth, skill was physical speed through motion economy. For the Red Seal Mason, skill is synthesized technical knowledge, the ability to interpret complex documents and apply material science while maintaining strict regulatory compliance. The modern Mason is a knowledge worker who happens to use a trowel.
So, if Gilbreth's methods tried to make an unskilled man perform like a journeyman through strict rule following, using a story pole, constantly checking the scoreboard, we have to ask the ultimate question about the future.
Right. If modern AR/VR technology can perfectly simulate real-world experience, offering immediate objective feedback and eliminating costly errors in a safe environment, essentially providing the perfect, consistent classroom Gilbreth dreamed of, does a 5,600-hour apprenticeship truly still need the full 4,880 hours of physical on-the-job training?
Has technology brought the classroom closer to the wall than Gilbreth ever imagined, maybe making that ratio of classroom to field hours obsolete? If you can master the knowledge and the motion in a virtual environment, what's left that only the physical job site can teach? That is a provocative thought.
The physical craft endures, and the lessons of Gilbreth, that waste is the enemy, will always apply.
Yeah.
But the transfer of knowledge is poised to change dramatically, perhaps fulfilling his original dream of eliminating the incompetent teacher, not with a megaphone, but with perfect virtual simulation.
Thank you for joining us on this deep dive into the time-traveling trowel. Keep your lines tight and your knowledge base even tighter. We'll see you next time.